Hello, this is Bruce Nielsen again. We are ready to finish off our basic retrieval augmented generation pipeline, or RAG pipeline. We almost completed it in the previous video, where we created a pipeline that retrieved embedded vectors of text out of a PostgreSQL database using pgvector. The only thing that we're really missing at this point is a large language model attached. So that's what we're going to do today, and that will be a basic RAG pipeline, and then we will expand from there in some more advanced videos talking about how to improve upon that. Before we get started, let me actually just cover a little bit more about installation and what environment you need set up. There shouldn't be anything different for this video than you had in the last one in terms of what was set up. And I actually suggested right here installing pip install bs4, ebooklib, pgvector-haystack, nltk, trafilatura, I don't know how to pronounce that, and sentence transformers. If you've actually already installed those, you've got everything that you need. However, I have found that sometimes this leads to some problems, so I wanted to explain a few things. So first of all, if you do bump into some problems, the first thing you should probably do is upgrade your pip install. So that would be python-m pip install -- upgrade pip. I kind of do that naturally, so I didn't think to put that in the previous video, but I was kind of assuming you were on the latest version of pip when you did this. If you've done that, then this pip install, that large list that we just did, it really should work. It may fail though in some cases, particularly if there's some sort of weird dependency problem. If so, you can always go back, do the pip install again and try it again. Or if you need to, do them as individual installs. Pip install bs4, then do pip install ebooklib, then do pip install pgvector-haystack, then do pip install nltk, etc. Until you get to sentence-transformers. By the way, I often forget the S at the end of this one and it causes a problem. It's sentence transformers, not sentence transformer. If you do those one at a time and there's a problem, you should be able to work through the problems and then get to the point where you've got the same environment that I've got. Once that's all set up, you're ready to actually work with the code that I'm going to give you in my Git repo here so you can look at how we actually set this up. It's very similar to the code that we wrote in the previous video. We're just adding a large language model onto the pipeline so that it runs through the same pipeline and then has a large language model actually process the results at the very end. If you do bump into any problems, let me give you a few websites that might be helpful. All of this you shouldn't need to have to do, but just having resources and documentation, I know that makes me feel more comfortable. So go to haystack.deepset.ai. We're going to go to integrations. This is where we went to before. And then we found the integration previously in the previous video for PostgreSQL, or pgvector actually. In this case, we're going to instead look for the Hugging Face integration. You can always get instructions there from that. So I'm just going to click on that, and it's going to give instructions on how to install pip install haystack-ai. That gets included for free when we do the PostgreSQL installation, so you shouldn't need to have to do this, but the documentation might be useful. Another website that I found useful is pypi.org, that's pypi.org/project/sentence-transformers. This is the installation guide for sentence transformers, if you need any documentation on that. And then you should get Hugging Face ecosystem, the Hugging Face hub, for free when you do the sentence transformers install. But if not, go to huggingface.co/docs/huggingface_hub/index, and that's going to have the documentation for the Hugging Face ecosystem, for the Hugging Face hub. And there's a quick start guide, and there's an installation guide. So if you do bump into any troubles, these websites should get you back on track, and you should be able to get caught up so that you can run the code that I'm showing you here. Let me give you a few other links that might be useful. So first of all, as always, if you go to the Mindfire tech blog and take a look at the artificial intelligence posts on the blog, you just have to go to mindfiretechnology.com/blog and then click on artificial intelligence. you'll see that there are some blog posts that really this video is kind of summarizing. In particular, this one, retrieval augmented generation with haystack and pgvector, and then a part 2, retrieval augmented generation with haystack and pgvector part 2. These blog posts give a more detailed account of what it is we're going to cover in this video about how I actually set this up, and gives information about how to set up environment and things like that as well. So those might be useful resources, these two blog posts in particular. Now, what is it we're really going to do here? Well, we're going to use Google's Gemma. So if you were to go to deepmind.google/models/Gemma, you're going to see that there's this web page for Gemma. Now, you've probably never heard of Gemma. You've probably heard of Gemini. But Gemma is a local model that is a quantized or reduced version of Gemini. So it's something that you can run on a laptop, particularly if you have a GPU. It should work pretty well. Even on my rather slow laptop with a pretty poor GPU, it's kind of slow, but I can still get results out of it. So Gemma is this open source version of Gemini, except reduced, so it's not as powerful, but it's able to be used in a local environment. And we're going to use that, and it is totally free because it's open source. Now, Google has put the open source version of Gemma out into the Hugging Face ecosystem. So if you go to huggingface.co/Google, you will find the organization card for Google. And if you scroll down, there is a list of the resources that Google has put up into the Hugging Face ecosystem, and it includes a lot of these different Gemma models. You can see that there's some that are like Gemma 3, 27 billion parameters. There's 1 billion parameters instead. This is where you're going to be able to sign up and get access to Gemma. Now, for our purposes, we're going to be using one of the simplest versions of Gemma. So scroll down and look for this Google/Gemma-1.1-2b 2 billion parameters-IT, and click on that. That's going to take you to huggingface.co/Google/Gemma-1.1-2b-IT. And this is the card for the model that we're going to be using. Now, you can see here, this is a gated model. I have been granted access to it. You're going to need to have a Hugging Face login to be able to get to this, and you're going to have to ask for access to Gemma to be able to use this. So that's probably the next thing you're going to need to do if you haven't done that already. Now, to be able to get your own login, you're going to need to go to huggingface.co, and then you're going to click over here on the sign up button. And that button's going to take you to this Join Hugging Face, where you can enter an email and a password, and you can start the account creation process. I'm not going to walk you through that step by step. It will lead you by the hand in setting that up when you get to the right page and you get started on this. And you're going to need this to be able to sign up to get Gemma. Finally, you'll come back to the Gemma page that we were on before. You're going to then have to, I can't show it to you because I've already got access to it, but you will have to sign up for Gemma itself, and then they will very quickly ask you some questions, and then will grant you access. And at that point, you now have access to the Gemma model, and you will be able to, using your Hugging Face login inside your code, you will be able to access Gemma, and it will download to your hard drive, and you'll be able to run it locally. Now, there's one more thing you're going to need off of Hugging Face. If you go up here, click on your profile, and go to Access Tokens, it's going to make me log in again. Here you can actually do, this is the Access Tokens page. You can see I've got some tokens. They're not visible, luckily, but you can do this Create New Token. And walk through that process to create a token. This is going to be the basis for how you're going to log into the Hugging Face ecosystem inside of your code. Now, finally, we need to get to the actual code that I'm going to be taking a look at. So if you go to my GitHub, so that would be github.com/Bruce Nielsen, BruceNielsen, click on repositories, and we're going to be looking at this repository called blog-posts. So I'll click on that, and the file that we're interested in is haystack_pgvector.py. .py. I will, of course, put all the links that we just talked about into the show notes when I put this up on YouTube, so you don't have to actually get the links or the URLs that I'm describing in this video. Let's now jump over to the actual code, and let's talk about what we've changed since the last time, since the previous video. I'm using the same code essentially just with some additional additions so that we can use Gemma as a large language model. So one obvious thing we've done is in the init for the class haystack pgvector, you can see I'm now allowing you to pass a LLM model name. And in this case, I'm defaulting it to Google/Gemma-1.1-2b-it. By the way, the IT at the end is kind of important. They have a non-IT version. You would probably not in general want that. If it has the IT at the end, that means that it's been set up so that it has like these instruction sets that you can use, kind of tags that you can use so that it knows when it's your turn to talk versus its turn to talk, things like that. It's a more useful when it has the -it at the end, so I tend to prefer those. So we're going to notice also that this is just a parameter, so we can throw in there a different Gemma model or even a non-Gemma model, and it's not going to really care. As long as it's something that's on Hugging Face, you're going to be allowed to pass in any model you want and use any model you want that your GPU can handle, or Gemma can probably be handled by a CPU. I've tried it. It's a little slow, but it works. And you're going to be able to pass that in and use that as your large language model with the pipeline that we built in the previous video. The other thing that you would notice is that I've added this place where you can pass in a Hugging Face password so that you can actually pass your Hugging Face password in. And then we've added some code into the init where I check to see if it has a Hugging Face password, and then I actually do hf_hub.login, and then I pass the password in. And in this case, I tell it to not add to the Git credentials. You could just have it so it saves that off. And so we've actually added it so that I'm passing the password. It logs you in, and from that point forward, you're authenticated, and it's able to use the Hugging Face hub to be able to download Gemma and to work with it. Now, the next section of code that I've added is still inside of the init function for haystack pgvector, but you can see that I've marked this warm up LLM generator. So now I've done a couple things here. You don't necessarily have to do this, but I like to actually use torch.cuda.isAvailable to see if there's a GPU or not, and actually detect if there's a GPU, and then I save that off as _torch_device, and I'm going to use that so that it will either use the CPU or GPU, and the code will work with both. I then have to create a component device out of this, so I say device.gpu, open and close bracket, and then I say if it has CUDA, else do device.cpu, and we're going to then plug this into the actual Hugging Face local generator. So Hugging Face local generator is something that's part of Haystack, and it's part of the Hugging Face integration inside of Haystack. And so behind the scenes, it's going to be using the Hugging Face hub code to be able to take the LLM that we've passed in, and it's going to, so you can see where I'm passing in the model name here as model, into this. I'm telling it that I want to do text generation is the type of task. I'm passing in a device using the component device of the one that we've already selected up above here. There's some parameters I'm setting, temperature, do sample, things like that. That's for more advanced situations. Max news tokens is kind of important. What that really is it's just telling it how many tokens it's allowed to generate on top of the tokens you've passed to it as part of it giving a response to you. And then you have this, once you've created this LLM generator, you do warm_up, open close parentheses, and then it's going to warm up the large language model for you that you can then use in your pipeline later. Now, next up, we're going to create a prompt template. So scrolling up here, self._prompt template, it's just a string. Notice that what we're doing here is it's a string that we're going to be passing to the large language model, and it's a template. So it's going to start of turn. Remember, the IT allows you to do tags that tell you whose turn it is, things like that. So start of turn user, and then we're going to say, quoting the information contained in the context where possible, give a comprehensive answer to the question. Then we do a context, and here we're going to say for doc in documents. Later we're going to pass in a documents to this, and it's going to iterate over documents. It's going to say doc.content, throw the content, iterate over and put the content for each document, and then you have an end for. This is the template portion. And then we say question. We throw in the query. The query is going to be the user's query. Then we're going to say end of turn and then start of turn for the model. Okay, so this is the type of template that we're going to end up building. And this is how we're going to allow what we've taken out of the pipeline, the documents that we found using the text embedding and doing the vector search. That's going to be inserted into the model's context window using the template that we've just built here. So that's really the big trick here. Now, the next thing, and I won't go into detail for this, but I do create a series of properties that are just helpful in terms of making the code more readable and easier for me to try to remember how things work. So for example, I have this property LLM context length. And what I'm actually doing here is I am calling haystack pgvector dot, and I call this other function. And it's a static method that I've built. It uses Hugging Face's autoconfig module from pre-trained. I pass in the model number, and it's going to come back and it's going to grab what the context window length is for this model. And so obviously it will try to adapt itself to whichever model that we pass in. What's a context window? That's how many tokens the model can see at one time. When you're using ChatGPT, eventually your conversation goes outside of its context window and just forgets everything. Same thing is going to apply to Gemma here. Now, using the same basic idea, I also have a, besides an LLM context length, I have a sentence context length. So that would be the context length for the sentence embedder, which would be hopefully a lot smaller than the large language model's context length. I've got the embedding dimensions for the LLM and the sentence embedding dimensions. Now, each of these in turn calls another function, which I wrote, that then uses the autoconfig and looks those up. And this is just so that we could have hard-coded all this, and it wouldn't have really made that much of a difference. But I wanted to make it so that no matter which model you pass in, it uses the Hugging Face autoconfig module to look up information that it can then pass in and it can use so that it understands how to do the embeddings in a appropriate way, things like that. Stuff that is a little more advanced, but we're kind of setting up for more advanced stuff in the future here. Now, the next function that we changed is under the haystack pgvector class. We've got this generate_response function. That already existed in the previous video. But back then, all we did was list out the documents that we returned. What we're doing here is we're going to add the LLM's response in addition. So once we remake the pipeline, besides just returning the documents, we're also going to return the LLM's response to the user, and we're going to print that on the screen. So that's what we've added to the generate response method. Now, one last thing I need to explain is I have created a custom haystack component just by putting this at component there. There's not much to it. All it's really doing is taking in a list of documents and a list of replies, which is a list of strings, and it just merges them together and passes them back out. This is necessary, though, for my pipeline to work correctly, where it's going to pull back the documents and also the replies and put them together into a nice little component that I can then read out of at the very end. With that all out of the way, we're now ready to actually build the pipeline. It's still a fairly simple pipeline. Let me take you through how it works. This is the starting point. And you can see that we pass in a string. That would be the user's query. And we're going to throw that into the component, the query embedder, which is a sentence transformer text embedder type. It's going to come back with a list of embeddings, which is a list of floats. And that's going to go into our retriever component, which is a pgvector embedding retriever haystack component. That's going to have a number of different parameters. That's what we see here, the filters, the top K, etc., that are set at the time of init for our haystack, the class that we're using. This is now going to pass the documents that it comes back with into the prompt builder. Notice that we've got two paths. So we're going to pass the list of documents directly down to that merger component so that we can actually list those off for the user. But we're also going to pass it to the prompt builder. The prompt builder is going to take that, insert the documents into the prompt that is sent to the large language model. That's going to become a string. It's going to be sent to a component, the Hugging Face local generator component. That's the LLM, named the LLM. It's going to then send back the reply of the large language model based on those documents and based on that prompt template that I showed you. Those get merged together. That gets passed back. And then I actually print both of those to the screen. So you ask your question. It says, here's the documents that it came back with, and then it gives the large language model's reply. And that's basically the whole pipeline right here that we're about to build. Okay, now let's actually take a look at the code that builds that pipeline. So we've got this underscore create rag pipeline method that I've built. Notice that this pretty much is exactly what I just showed you in that graph. So what we're doing is we start with creating the prompt builder. We call the prompt builder, instantiate it. We put the prompt template into it. We're going to build a rag pipeline using the haystack pipeline type right there. Then we're going to build a number of components, and you can ignore the PyCharm warnings here. This really will work. We've got a sentence transformer text embedder that we're going to be calling query embedder. We've got a PG vector embedding retriever, which we call retriever. We've got the prompt builder that we built here, which we call prompt builder. The LLM generator that we've already warmed up, that we call LLM. The component to merge all the results, which we call merger. And then we connect them. So query embedder embeddings connects to retriever.query embeddings. Retriever.documents connects to prompt builder.documents. Prompt builder.prompt connects to LLM.prompt. Retriever.documents connects to merger.documents. LLM replies connects to merger.replies. You can see how I've kept all the names exactly the same to make it as easy as possible to see how they're connected. And notice that this is exactly what I just showed you on the graph. That's because obviously I built this, and then the graph is built by Haystack out of the pipeline that I built here in the code. And then finally, that new pipeline gets saved off as a property that's inside the class. And that's what we're going to be working with. And finally, we've got the actual main function that we call. You can see here that I'm doing my little trick where I put the Hugging Face secret that we generated as a token earlier in this video. I pull that out of a text file so I don't have to store it in Repo anywhere. That's the secret that we're going to pass in. I'm going to create the haystack PG vector. That's our class that we've just been going over in this video. I'm going to pass in a table name. In this case, I'm going to say, yes, we want to recreate the table. Normally, you'd probably want to put false for that, but I just want to start fresh to demo this. The book file path, I'm going to actually put the path of where to find the book. You can see that that's federalistpapers.epub, which is inside the repo. Pass in the secret. Then I draw the pipelines using the RAG processor there. And then it's going to run this generate response and pass in the query. In this case, the query is, what is the difference between a republic and a democracy? And this is the same as it was before, but now we've already modified this generate response to include the large language model's response. Okay, let's go ahead and run it. And this takes a little while on my laptop. I will obviously shorten this down for your sake, but we will run this, and it will now add in, just like it did before, it's going to come back with the best semantic search hits that it can in terms of documents, but it's going to throw in there the additional large language model reply. Okay, notice here that we are now taking the Federalist Papers and we are breaking it into paragraphs, and we're embedding them creating a embedded vector out of each of the paragraphs and putting it into PostgreSQL. This is the same as what we did in the previous video. Okay, now we have finished writing the documents out to the document store. So now the next step in the process is that it's going to take the large language model, and it's going to send the results off to the large language model so that it can give us a response. So here it says the number of documents that it came back with was 1,554. That's how many it embedded total. Obviously, that's not how many the large language model is reviewing. And it's now warming up the large language model, and you can see that what it's going to do next is, if this is the first time you've run it, it's going to download Gemma, and it's going to put it onto your local hard drive. It probably goes pretty fast if you've got a decent GPU or quite a bit of memory. Then it just needs to load it off into memory so that it can use the large language model. All right, so now it's loaded up the large language model, and it's going to now come back, and it's sending the documents off to the large language model, and it's built the prompt, and it's going to generate a response. And once it generates the response, it's going to return all the documents that it used. It will be, I think it's a top 5, or maybe it's top 10. I forget which one I did. And it's going to then generate a response based on those documents. All right, we finally got a response back. So retrieve documents, it's going to go through the top 5, it looks like, retrieve documents that it came back with. You can see that one of the answers was this one: the 2 great points of difference between a democracy and a republic are. So obviously that's probably one of the best answers. These 5 documents get fed to the large language model, and then the large language model comes back with an answer. Difference between a republic and a democracy, you can see it's using Markdown, even though we're just doing this command line. And then it says, delegation of governments. In a republic, power is delegated to a small number of citizens elected by the rest. In a democracy, power is delegated to the government as a whole. So, I mean, like, it's going to then give more of an answer here, but it's answering the question based on the documents that we fed it. So this grounds the large language model's response against the documents that we sent it first. Now, it might still hallucinate. It might still make something up. I've seen it do that. But you're reducing the chance of hallucination here, and you're kind of corralling it so that the large language model is going to give a response that's appropriate to, in this case, the Federalist Papers. And it's going to come back with the answers, and it's going to have the best hits paragraphs from the Federalist Papers right in front of it as it gives its answer, and it kind of helps direct the large language model towards giving an appropriate answer. And that's really the whole secret, right? This is what we're doing with a retrieval augmented generation pipeline, is we're pulling back documents and we're grounding the large language model's responses against those documents that we have pulled back. It doesn't have to be documents. It could be API, maybe get the weather, get the temperature. It could be that we'll see when we do videos on advanced versions of this, where maybe we allow it to do things like set up ticket sales or something along those lines. And so this is the power of retrieval augmented generation. And that's it. We actually now have a working retrieval augmented generation, or RAG, pipeline. And notice that it didn't take that many videos. It wasn't really that difficult. Artificial intelligence is not that hard to add to your applications. And that was really the point I was trying to make. Now, obviously, there's a lot more that we could be doing here. This is the most basic RAG pipeline that we could possibly have done. There's so much more that we could do or learn that would be advanced techniques that would make this a lot more useful. And we will do future videos on those. But in the meantime, that's it for now. Don't forget to like and subscribe, and we will see you next time.